Quantum computing breakthroughs. Japan's $335 million investment. Global Milestones explained. This week in quantum computing, we're witnessing a significant push towards commercialization, with major players like Japan, Canada, Israel, and Singapore leading the charge. Imagine a world where quantum computing isn't just confined to labs, but is integrated into everyday business processes. That's the direction we're heading, and today's news signals a major step forward. Japan's Ministry of Economy, Trade, and Industry has made a substantial investment of $335 million to propel its quantum ecosystem. This ambitious plan involves funding over 10 companies, including tech giants Fujitsu and KDDI, to develop both hardware and software solutions. But here's where it gets really interesting. The government's goal is to establish Japan as a leader in quantum software, an area that hasn't seen a clear frontrunner yet. They're also building a new facility called Qubit, which will serve as a collaborative hub for businesses and researchers alike, fostering innovation and skill development. Meanwhile, in Canada, Xanadu and HyperLight have made a breakthrough in low-loss quantum photonics. These companies have developed thin-film lithium niobate chips with incredibly low waveguide losses, below 2 dBs per meter, and switch losses around 20 milladecibels. These achievements are groundbreaking because they bring us closer to practical, large-scale quantum systems. The chips are being manufactured in a high-volume semiconductor plant and will be integrated into Xanadu's Aurora system, which operates without the need for cryogenic cooling, making it more accessible and efficient. On the other side of the globe, an Israeli startup named Quantum Art has hit a major milestone by creating a 200-ion linear chain. This advancement is crucial for scalable quantum logic operations. Quantum Art is working on a 50-qubit system for commercial use and plans to launch a 1,000-qubit platform by 2027. Their innovative approach avoids the need for ion shuttling or photonic interconnects by using optically segmented cores that operate in parallel, showcasing a different path to quantum computing. Another Israeli company, Classiq, has secured funding from SoftBank Vision Fund 2 and CDP Venture Capital, bringing in new capital to further develop its quantum software platform. Classiq's technology allows enterprise developers to create and run complex quantum algorithms without delving into hardware-specific code, making quantum computing more accessible to a broader range of businesses. In Singapore, Horizon Quantum Computing has joined the Qubit Quantum Alliance, aiming to enhance software tools for neutral atom quantum systems. Qubit, a prominent player in this field, uses arrays of neutral atoms for scalable quantum processing without relying on ion traps or photonic links. Horizon's contribution to the alliance, which now includes over 25 members across North America, Europe, and Asia-Pacific, is in developing automated algorithm synthesis and compilation tools that simplify quantum programming. These developments are not just theoretical. They represent real progress in turning quantum computing from a niche technology into a viable commercial solution. For investors, keeping an eye on companies like IBM, Alphabet, and IonQ, these milestones indicate a shift towards practical applications and commercial platforms. But here's the part most people miss. While these advancements are exciting, they also raise important questions about the future of technology and its impact on industries. Will traditional computing methods be overshadowed by quantum computing? Or will they coexist? How will this technology transform fields like finance, energy, and healthcare? These are the kinds of discussions we need to have as we move forward. So, what do you think? Are you excited about the potential of quantum computing? Or do you have concerns about its implications? Share your thoughts in the comments. Fujitsu's 250-qubit quantum computer ambitions for 2030. Star architecture innovation. Imagine a world where Japan leads the global race in quantum computing. Fujitsu is setting its sights on this ambitious goal, aiming to develop a world-class superconducting quantum computer by 2030. This isn't just a lofty dream. It's a strategic partnership with RIKEN and the National Institute of Advanced Industrial Science and Technology, AIST, that could revolutionize the tech landscape. The new model, slated to feature around 250 logical quantum bits, or qubits, will leverage advanced cooling methods to ensure peak performance. But here's where it gets controversial. While this initiative is a significant step forward, it also raises questions about the global balance of power in quantum computing, with the US and China currently leading the pack. Fujitsu's move is a clear attempt to catch up and potentially surpass these giants, leveraging the expertise of its partners to build a state-of-the-art quantum computing system. This system aims to handle complex computations more efficiently than classical computers, a feat that could transform industries from finance to healthcare and logistics. However, the development of such a quantum computer is fraught with challenges. The technology requires precise control and cooling to maintain qubit stability, and the integration of quantum algorithms and software is a critical aspect that cannot be overlooked. Yet, Fujitsu's partnership with RIKEN and AIST, both renowned for their advancements in quantum technologies, positions the company well to overcome these hurdles. This initiative is part of a broader trend in the quantum computing industry, where companies are investing heavily in research and development to stay competitive. For instance, D-Wave Quantum Inc. has been working on advanced cryogenic packaging for its quantum processors, while companies like Classiq and Horizon Quantum are expanding their funding rounds to accelerate product development and partnerships. The success of Fujitsu's quantum computing initiative could have significant implications for various industries, including finance, healthcare, and logistics. Quantum computers have the potential to solve complex problems more efficiently, leading to breakthroughs in drug discovery, financial modeling, and supply chain optimization. However, the development of quantum computers also poses challenges related to security. According to a report by Keyfactor, nearly half of enterprises are unprepared for post-quantum cryptography threats, which could render current encryption obsolete. Companies like BTQ Technologies are addressing these security concerns by developing quantum-secure blockchain frameworks. As Fujitsu's quantum computing initiative progresses, it will be crucial to monitor its progress and the broader advancements in the field. The success of this project could pave the way for Japan to become a leader in quantum computing technology, with potential implications for the global economy. And this is the part most people miss. While the technological advancements are exciting, the ethical and security implications are just as important. How will these powerful machines be regulated? Who will have access to them? And what about the potential for misuse? These are questions that need to be addressed as we move forward into this new era of computing. What are your thoughts on Fujitsu's ambitious plan? Do you think Japan can catch up to the US and China in quantum computing, or will it face insurmountable challenges? Let's discuss in the comments.